So section 2 of our conics is going to be talking about the ellipse. We can look at the definition of ellipse as the set of all points such that the sum of its distances to two fixed points, which we call the foci, is constant. So what that means is any of these points that you would pick on this ellipse as you're going around, if you were to connect to each of the foci and add those two distances together, it's always going to be the same. And we saw that demonstrated in class with the string on the board, if you recall. The equation of an ellipse is given like this, where you have x minus h quantity squared over a squared plus y minus k quantity squared over b squared. And that's going to equal to 1. And we really like our equation in this form because it tells us so many different things. So first of all, what it's going to tell us is what the center is at h and k. And then the second thing that it's telling us with the number a and the number b below is that's how far you're going to move away in the x direction and the y direction from that center. So you know exactly how big your ellipse is going to be. So if your equation is not already in this form, you're going to need to do some calculations, maybe complete the square, divide through by a number, whatever, so that you get it to look like this format. Okay, so let's look at an example. We have 4x squared plus 9y squared is equal to 144. So right now, it's not in our nice pretty form, so we're going to divide through by 144. And when we do that, we now have our center is at 0, 0, and we can look at the square root of each of these numbers to get a and b. So 6 squared and 4 squared. Okay, so let's go ahead and start graphing here before we do anything else. The center's at the origin, and then we're going to move 6 units in the x direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 4, 1, 2, 3, 4, up and down. Okay, and then we're going to get our little ellipse tool here because it makes graphing these things so much easier. At least on the computer, anyway. All right, there we go. Okay, so we have a nice, beautiful ellipse here, and you can kind of see how this ellipse could have been a circle if that had been a 6 instead of a 4. Because if it was 6, then it's a uniform distance from the center all the way around, making a circle. Okay, so the second thing was to state the x and y intercepts. Well, that's fairly easy now that we have these 4 points because those are your x and y intercepts. Okay, so 6, 0, negative 6, 0, we have 0, 4, 0, negative 4 for x and y intercepts. The last part asked us to find the length of the major and the minor axes. Well, the major axis is the long one, obviously, major, and then the minor axis will be the short one. So you just, to figure out these distances is from this point all the way to that point. Well, each of these was 6 units, so the major axis is going to be 12, and then each of these is 4 units, so the minor axis will be 8. Fairly routine calculations. Okay, so let's take a look at something else here. All right, so in class we derived this equation to figure out what C is, and remember that C is going to be the distance between the center and each of the foci. So we're going to need to do that calculation by taking a squared and subtracting b squared. Or if b were larger, you would take b squared and subtract a squared. We want it to be positive. So it really doesn't matter which one you call a and b as long as you are taking the larger one and subtracting the smaller one. Okay, so let's try another example. This one says find the center, foci, and to graph. Okay, well the center is the origin. We're going to take the square root of our denominators. So here's our center. Moving over 2 in the x direction and at 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay, and let's see here. Okay, so there's my ellipse. Next thing was to find the foci, right? So to figure out your foci, we're going to use our equation up here. We're going to take the 25 and subtract the 4. Don't do the 5 and the 2. It's the squared, remember. So 25 minus 4 is 21, and the square root of that is plus or minus root 21. So we have the plus or minus in this case, well, even though it says c is the distance between, because we are going to be adding and subtracting. We have to go up and down to get to our foci. So how do you write those coordinates out? Well, from here, we're not moving anywhere in the x direction. We are going to be moving up root 21 to get to one focal point, and then we'll be moving down root 21 to get to the other one. And all you have to remember is that your foci are always going to be on the major axis. So once you've graphed it, you should have determined which one is the major axis. Or you can just look at it, the larger number was under y, so we're going to be adding and subtracting it to the y coordinate. Okay, you don't have to graph the foci, but if you had to, you would figure out what is the square root of 21. It's a little bit more than 4. We could put those points, you know, somewhere around here, somewhere around there. Okay. But it didn't ask you to do that. All right, so moving on. Next one, find the coordinates of the center and foci and graph. Okay, so this time we need to divide through by 16 first. And this case, we have a center that is not the origin, so we haven't done one of those yet. Okay, so reading off what the center is, the opposite of this and the opposite of that, 1, -3. Let's plot it. So go over 1, 1, 2, 3, down. Okay, next. So we calculate out what the square root of our denominators are. So we're going to be moving 2 units in the x from our center, not from the origin, but from our center. 2, 1, 2, up 4, 3, 4. Oop, ran off my graph. Oh well, it's roughly there. Okay, so let's graph that. Okay. So figuring out our foci, once again, you take 16 minus 4 and then take the square root of that, so plus or minus 2 root 3. Remember that we are going to add and subtract this to the y coordinate of our center because our y direction is the major axis. So our foci are going to be somewhere here and here. I'm not being very accurate. I don't really care because it didn't ask me to graph it, but what that's doing is giving me a reference so I know which one to add and subtract it to. So the x-coordinate of the blue points is going to be the same as the x-coordinate of my center, so it's going to be 1. And then the y-coordinate, what I would be doing to get to here, is I would be going down the 3, so that's the -3, but then I add 2 root 3. Or to get to this focus, I would be going down 3, so -3, and then I'm going to subtract 2 root 3, so a little bit more, to get down there. So logically, when you go to do the math for this, the y or the x coordinate is going to be 1, and I'm going to take the y coordinate for both of these, and one of them I add the 2 root 3, and the other I subtract the 2 root 3. So trying to keep that straight, and if you need to graph the foci to help you out, by all means go ahead and do that. Okay, if this had a major axis that was horizontal instead of vertical, we would be adding 2 root 3 to the 1 and subtracting it from the 1 and then leaving the y coordinate the same. You'll see that in your assignment. Okay, so let's see, one last thing. They ask you to find the equation of the ellipse with the given information, and that is that the x-intercepts are plus or minus root 7, and the y-intercepts are plus or minus root 3. Well, that implies that the center is going to be at the origin. So we know that the equation for the ellipse is going to look something like this, where we have to fill in our denominators ourselves, right? So we know it's going to be an x squared plus a y squared. It's going to equal 1. We just need to figure out what goes underneath the x squared, what goes underneath the y squared. So the x-intercepts, remember, if we take root 7 That means you're moving root 7 in the positive direction and the negative direction away from the center. So that's actually a, right? So what we're going to put under here is root 7, but we have to square it because it's a squared. And then the root 3 plus or minus, we're moving up root 3 and down root 3 from the center. And so that's going to be b, but we have to square it. Now you just have to simplify and you get your equation. So it's all a matter of just like working backwards from what we were doing before. Okay, so that's the ellipse. I hope that wasn't too confusing. And we'll have lots of practice with that.